The only thing better than Python, they say, is Python with modules. Hey everyone, it's the Future Programmer here. In this Python Fundamentals tutorial video, you will learn all about what modules are, how they work in Python, and how you can use modules in your own Python programs. So with that said, let's get started. One of the many things that make Python such a beloved and popular programming language among developers is its support for modules, making it a modular programming language. With Python, programmers can do many different things like machine learning, artificial intelligence, data science and visualization, game development, web development, and many more. And this is because of Python's support for an absolutely enormous number of built-in as well as third-party modules that we can install. And in this video, you'll learn all about what modules are and how you can use them in your own programs. To start off, what are modules? Now, module can be somewhat of an intimidating word at first, but really is just a fancy word that describes a Python file. So any of the Python files that you have written so far can be considered a Python module. You can also think about a module as a library of Python source code that we can use over and over again. In Python, modules can be built in, user-defined, or installed. A built-in module is a module included in the Python standard library, which gets installed on our computer when we install the Python interpreter. A user-defined module is a module that we as programmers write ourselves and use in our own programs. And installed, also known as a third-party module, is a Python file that other people have written before, which we can install on our own computer and use in our own programs. There are many reasons why modules are super useful in writing Python programs, and one of the main ones is it allows us to organize code meaningfully. So for example, let's think about if we're writing a 1,000-line program for a video game. Now, perhaps we can include all of the code in one file, but it is ideal to separate related parts of the program into their own files so we can easily access and debug them. So for example, we can have a file that handles the graphics of the game called graphics.py, and we can have another file that handles the characters, the players, the enemies, etc., and we can put that in one file. Lastly, we can have another file called main.py that ties everything together. And that is really the power of modules in Python. Now you may wonder, how can we make a module? Well, any file with a file extension .py can be considered a Python module. So a.py, b.py, helloworld.py, they are all considered Python modules. And any of the code inside those files, the variables, the functions defined, and the classes can all be used in other modules. Now, it is easier for me to demonstrate modules in a code editor since we'll be working with multiple files at the same time. So I've opened Sublime Text and made two files in them. Let's take a look. In Sublime Text, you can see I have a folder called modules, and in this folder I have two files, a main.py file and a module.py file. Let's first take a look at the module.py file. In here, you can see there are three things. There's firstly a variable x, which has a value of 2. I've also defined a function called myFunction that takes num as a parameter and prints out num and an exclamation mark. Lastly, on line 9, I have defined a class with a class variable called a, which has a value of true. Now, how can we use those inside another file? Well, when we want to use a module, we need to first import that module into our program. And if the name of our module is m, we can simply write import m at the top of the other file. So let's take a look. So right now I have the file module.py open. And in main.py, in this file, I can just write simply import module. Module has to match the name of the py file, so excluding the .py extension, whatever this is will be whatever is written here. So if I change this to, for example, A, which doesn't actually change the name of the file, let's just pretend that the file name is now a.py, then I'll have to change this to import A. And Python will automatically look at different locations on your computer, including the current working directory, to look for files that match this module name. But since this file is actually module.py, I'm going to keep this as import module. When we want to access the members of a module, we can use what is known as dot notation. So now that I've imported module, I can access and modify the members of module.py, which are x, my function, and c. So if I want to access the x variable, I can simply write module, and then a dot, and then x. And if I want to call the my function with a parameter of 2, I can simply write module, and then dot, and then the function name, with the function call, the parentheses at the end with the parameter inside. Lastly, if I want to access the class C of the module, I can simply write module.c. And since I want to access the class variable A of the class C, I can just write module.c.a. And running the code, you'll see 2, and then exclamation mark, and then true as the output. You may have also noticed that on the sidebar, there's a new folder generated called PyCatch. This is normal, and this is just a bytecode file generated by Python. You can see this is pretty much just machine code. You can also feel free to delete this file because it will be generated every time this statement is run. If I want to modify the members of a module, I can do so just as how I would modify any other variable. In this case, let me comment those out, and you'll see if I write module.x plus equals 2, then the variable x from the module file will be incremented by a value of 2. So now module.x should be a value of 4 since it was originally a value of 2. Let me save this and run this, and you'll see the output of 4 is indeed displayed. Now, sometimes we don't want to import everything from a module. Yeah, this is just a summary on how we can use members of a module. We can just use the dot notation. Now, sometimes we don't want to import everything from a module, and we only want to import the things that we need, which would increase the speed of the import as well as avoid namespace pollution. And so now let's go back and take a look here. If I don't want to import x, my function, and c, I just want to import x and my function, I don't need c, for example, then I can write this. I can write from module, I will import those things. Notice how this is separated by a comma. So x, and then comma, my function. And when I now access those members of the module, I do not write module.x, I don't write module.myfunction. Instead, I simply write x because we have not imported module, but instead imported those things from the module file. So if I run print x and then my function with a value of 2, you'll see the value of 2 and 2 exclamation mark as the output. However, when I try to print out module.x, you can see a name error raised telling us that name module is not defined because we imported only those things and not the module file. And so we can't access the module name. And sometimes you'll see people writing from somewhere import asterisk. Let's take a look at what that is. When I want to import everything from a module, I can write from that module, import, and then asterisk. And that will import everything from a module. Let's take a look here. So from the module, I will import asterisk. And now, just like how when I imported X in my function, I can directly access the class C as well as its attribute A. So I don't have to write module.c.a, I can just write c.a. And if I run this, you'll see true as the output. And after this statement, I can also access the X and my function members of the module file, since this imported everything from the module file. The next thing I'm going to talk about is aliasing modules using the as keyword. So when we were importing a module, we can also rename it using the as keyword. And this will allow us to write sometimes shorter code and in certain situations follow the industry standard convention. For example, with a lot of data science and machine learning packages, there is a standard convention of how they should be renamed when we import them. So if I want to import the module file as something shorter, for example, M, then I can write import module as M. And Python's a great language because it's super readable. So I can just read import module as M. And now I have M, so I can write m.x, which will give us an output of 2. But when I try to access module.x, you'll see the name module is actually undefined. So when we imported module as M, module no longer exists, it's now called M. So this statement will give us a name error telling us module is not defined. Last but not least, I'm going to talk about how we can check the members of a module using the dir function. So when I want to check the members of a module, I can simply use this function and pass in the module into this function call. So let me comment these lines out and uncomment those lines. We can see if I write import module and pass in module into the dir function, the dir function is going to return a list of strings. And among these strings, there is C, there is my function, and there is X. You'll also notice those strings with underscores before and after the names. And those are just some members of modules that is kind of by default exists with modules. Don't worry about them. And just you can find out that all the members that I have defined in module.py are in this list. So C, my function, and X. So to summarize, I hope you took away from this video that modules are really super powerful and super useful. Perhaps right now you feel like it just allows us to organize code better, but trust me when I say that after we talk about the built-in modules and third-party libraries, packages, and modules, you'll have a better understanding on what modules can truly do. So to end the lesson today, we talked about what modules are, how we can make a module, and the different ways of importing a module, as well as how we can check the members of a module using the dir function. And there you have it, modules in Python. In the next video, we're going to learn about some of the most useful and important modules included in the Python standard library. In the meanwhile, don't forget to like, share, comment, and subscribe for more videos like this one. With that said, thank you very much for watching, and I will see you in my next video.